Okay, so I want to talk to you about the standard deviation of the regression line and how we use that to find outliers. So once you find the least squares regression line, the next step is to examine how effectively the line summarizes the relationship between X and Y. Important questions to consider are: one, is a line an appropriate way to summarize the relationship between the two variables? Two, are there any unusual aspects of the data set that you need to consider before using the least squares regression line? And if you decide that it is reasonable to use the regression line as a basis for prediction, how accurate can you expect the predictions to be? You need to know what a residual is, okay? And so what is a residual? Okay, it's a vertical deviation of a point. Okay, so over here in the diagram, you've got the blue line, which is the regression line. And here's a point from the sample right here. And here's another point from the sample right here. And this distance, this vertical distance that this first point is away from the regression line, so the distance, the length of that dotted line right there, that is the residual of this point. So each one of these points has a residual. It's nothing more than the length in the vertical direction that the point is away from the regression line. And if your data set has a good fit, then all of these residuals should be pretty small, okay? And when we go to find the least squared line, I've got, notice right here, I've got 5 points, A, B, C, D, and E. I've got 5 points in my scatter plot. And each one of these points has a residual, right? If you look at point E, this line here, or this line segment, right? This distance would be the residual for point E, right? So each one of these points will have a residual. Point D, this length right here is the residual for that. And that length, it looks like it's about 3. So the length is about 3. And if you take that residual length and square it, you're going to get about 9. Okay. And when you find the least squares regression line, what you're doing is you're finding the line that will give you the smallest sum of squares. Okay, so there's 5 points and 5 squares. Okay, take a look at point E first. Okay, point E has this length as a residual. That length is 1. If you take 1 and square it, you're getting about 1 back. So the area of this square right here is about 1, and the squared residual is 1 for that point. This point D here, the residual is this length, which is 3 units long and about 3 units. When you square that residual length, you get about 9, or the area of this brown square here. So each one of these points has a residual length, and when you square that residual length, you could visualize that as the area of a square, these brown squares here. And notice that if you add up all the numbers in the squares, right, if you sum up all of the squares, we're going to get 9 plus 9, that's 18, 19 over here, 20 plus another 4. So we're getting about 24 for the sum of the squares right here. And if now watch what happens if I click on this, you can see the green line now is the least squared regression line. And here's what I'm going to do. I'm going to take the red line, which is a guess at what the least squared regression line could be, and watch what happens when I take this point and I try to make it closer to the regression line. Notice what happens to the sum of squares value up here. As I move that point F on the red line towards the regression line, see what happens? The sum of squares is getting smaller and smaller and smaller. Okay, if I put the red line right on top of the regression line. Okay, so the thing about the regression line is that it's the line that best fits the data. But what do we mean by that? We mean that the sum of all the squares of the residuals, this number here, should be the smallest. So if you guess that the red line here is the least squared line, you'd be wrong, because the sum of the squares of the residuals is 21.8. But when you take a look at the regression line, the sum of the squares is about 18. So the least squared regression line is the line that has the sum of all the squared residuals being the smallest. Okay, that's why it's called the least squares regression line. The point here I'm trying to make is get you to understand the standard deviation again, and then of course how we use that to find outlying data values, outlying points. Okay, so to understand standard deviation, you know what the concept of a residual is, right? Each one of the points has a residual distance, or a distance that it is below the regression line. The standard deviation of the least squares regression line, that's going to be a measure of how far a typical point will be above or below the least squared line. So another way of saying that is that the standard deviation of the least squared regression line, it's the average distance, or the distance you would expect a point to be away from the regression line. So furthermore, regarding the standard deviation of the regression line, okay, if you have a, let me focus in here. If you have a small value of standard deviation, then that indicates that your residuals tend to be small. That would indicate that these distances are small. In other words, that the points are close to the best fitting line. Okay, so a small value of standard deviation indicates that the residuals tend to be small, and because residuals represent the difference or the distance between a predicted Y value and an observed Y value from the sample, the value of SE, the standard deviation of the least squared line, it tells you this, how much accuracy you can expect when you're using the least squared regression line to make a prediction. So if we've got a small enough value for standard deviation and the value of R is significantly close to 1 or minus 1, then we're going to get an accurate estimate using the least squared regression line. The formula for standard deviation is this nasty thing here. It just takes the sum of all the squares of the residuals and divides that by n minus 2, and then takes the square root of that. And they're using n minus 2 because there's two estimates being used in the calculation of standard deviation. And in this formula, n is the number of ordered pairs or points in the sample. The good news is you don't have to use this formula to find the standard deviation. I would just show you how to do that using a LinReg TT test on the calculator. Let's talk about what outliers are briefly. I think we already did, but anyways, here we go. In some data sets, there are values or observed data points called outliers, and outliers are observed data points that are far away from the least squared line. They have large errors, where the error or the residual is the vertical distance from the line to the point. Outliers need to be examined closely. Sometimes for one reason or another, they should not be included in the analysis of the data. It is possible that an outlier is a result of erroneous data. Other times, an outlier may hold valuable information about the population under study and should remain included in the data. The key is to examine carefully what causes a data point to be an outlier, and there should be some discussion amongst the research group about whether or not to keep that outlier in the data set. And it's always a good idea to address the outlier, why you think you might have gotten an outlying data value. But if it's just a mistake, then I would just remove that. So right over here, besides outliers, a sample can also contain one or a few points that are called influential points. And influential points are observed data points that are far away from the other observed data points in the horizontal direction. So besides outliers, you could have influential points, and those are the points that are far from observed data in the horizontal direction, as I was just showing you. These points can have a big effect on the slope of the regression line. So to begin to identify an influential point, you need to remove it from the data set and see if the slope of the regression line has changed significantly. And in practice, we use computers, software, and even calculators to identify outliers and influential points as well. So talking about identifying outliers, okay, and I showed you this the other day, but we'll get into it again briefly. So we could guess at outliers by looking at the graph of a scatter plot and your regression line and then just taking a visual. But we'd like to have some guideline as to how far away a point needs to be in order to be considered an outlier. So then as a rule of thumb, this is the guideline that we use. We flag any point that is located further than 2 standard deviations above or below the best line as an outlier. And so the standard deviation used is the standard deviation of the residuals, okay? We can do this visually in the scatter plot by drawing an extra pair of 2 lines that are 2 standard deviations above and below the best fit line. Any data points that are outside of this extra pair of lines will be flagged as outliers. Or it's possible to do it numerically by calculating each residual value and comparing it to twice the standard deviation. But it's so much work. The graphical approach is a lot more easier, and that's what I showed you the other day. The standard deviation can be used to find outlying data points, and here's how we do it. We use this guideline. A point is an outlier if it is more than 2 standard deviations above or below the regression line. To determine if that point is an outlier, we do the following. We input these equations and these 3 equations into our calculator. Y1, the regression line. And over here on my diagram, that's this black line, the regression line. Y2 is the line Y1 plus 2 standard deviations. That's the parallel line, or the line parallel to the regression line, this red line, which is 2 standard deviation lengths away. So this distance right here would be 2 standard deviations. And this distance from the regression line to Y3 would also be 2 standard deviation lengths. Okay, so we're finding these 3, or we're inputting these 3 equations in the calculator, with Y3 and Y2 being Y1 plus or minus 2 standard deviations. Okay, and once you take a look at your graph with the 3 lines on it, then if any point is above the red line or below the blue line here, then that point is considered to be an outlier. Okay, suppose we've got a random sample. I hope you've got your calculators out. We'll do this together. So here we go, a random sample of 11 students produced this data down here. X is the 3rd exam score out of 80, and Y is the final exam score out of 200. So can you predict the final exam score of a random student if you know the 3rd exam score? So and another question I'd like to answer is, are there any outliers? Okay, so first thing we need to do is enter that data into the calculator. I'm going to make sure that, click on Y equals and make sure that everything's cleared out of there. Make sure you've got all your functions cleared out there. Okay, that's good. And then I'm going to enter my data. I've got to clear out my lists here. All right, so let me zoom in. Maybe you can see the data a little bit better. Okay, so I want to go ahead and find the equation of the regression line, find the value of R to see if the correlation is strong, and take a look at the graph. So I'm going to go ahead and, first I'm going to graph it. So I'm going to press second Y equals, open up my stat plot, make sure that thing is on, make sure the first plot is selected. And then when I press graph zoom 9, graph zoom button, and then 9, that should give me the same picture here. So that looks like it's about the same picture, I think, here. Yeah, okay. Alrighty, so one quick way to get the regression line and the standard deviation is to run the LinReg-TT test. The LinReg-TT test. And to get that done, you're going to press the stat button. Right arrow over to the test drop-down menu. And then I'm scrolling down or up until I find LinReg-T test. And then I'm going to hit enter. And you should get this settings window here. Make sure your X list and Y list is pointing to where you have the data. Okay, and your frequency needs to, this next line, don't worry about it. But you do want to have right here, you want to have your regression equation stored as Y1. So what we're going to do here is we want to put Y1 in where the flashing cursor is. And what that does is we're going to tell the calculator to find the equation of the regression line and store that equation in the calculator as the variable named Y1. Okay, so as soon as we paste in Y1 here and calculate, the calculator will store the regression line as Y1, and it'll be easy to graph. So to get Y1 here, where my cursor is, you're going to press the vars button, right arrow over to Y vars, and then hit enter twice. And that should plug in or paste in Y1. I'm going to press calculate. And I'm getting this screen here, which is telling me that, we'll scroll down here. Some of this stuff I don't make sense of until later. But what we can get for now is, did I skip over my value? Okay, so my value of R is about 66%. So that's a moderate correlation, moderate positive correlation. And also the equation of the regression line is, it's supposed to be Y hat, but this calculator can't do Y hat, so it just does Y. And it's equal to, remember, A plus BX. And of course, the A and B are given to us here. Okay, yeah, it's Y hat equals negative 173.5 plus 4.8 X. Okay, so I've got my value of R and I've got my regression line. And notice also right here, I'm getting the standard deviation value. So this is the standard deviation SE of the regression line. So that's pretty large. 16 is pretty large. And so anyway, to use that to find outliers, we're going to use this guideline here. We want to tell the calculator what these 3 lines are and then have it graph the 3 lines. So to get that done, I'm going to press Y equals. And when I do that, notice that the calculator already pasted the regression line into Y1 for me. So that's the regression line. I'm going to arrow down, and I need Y2 right over here. I need Y2 to be Y1 plus 2 times the standard deviation. Standard deviation was 16. Okay, so now I want to define Y2 as Y1 plus 2 SE. So that, how to do that? I'm going to put Y1 in now where my cursor's at. To get that done, I'm pressing the vars button. Arrow over to Y vars and hit enter twice. that pastes in y1 plus 2 times the standard deviation, which we found was 16 when I hit enter. And now this third line needs to be this bottom line, the blue line here, and that's going to be y1 again. So to get that, I'm pressing vars, arrow over to y vars and hit enter twice. And then it's minus 2 times the standard deviation, which is 16. Okay, and then I'm going to graph all of these lines here. And it looks like there might be a point outside of this band. It looks like this point here could be outside. Let's see, can I zoom in? Let's see, I'm going to press my trace button. When I do that, it puts me on that point. How lucky. And can I zoom in? Press zoom and then 2 for in. I haven't zoomed in yet until I hit enter. And right there where my cursor is right next to, see, my cursor is moving up, but this right here is the actual point from the data. And you can see that point is outside or above this line Y2. So we do have an outline data value. And let's see if I can find the coordinates of that are roughly 65 and 175. Okay, so graphically, we didn't do it numerically, but graphically, we have identified the point 65, 175 as an outlier. And we should re-examine the data for this point to see if there are any problems with the data. If there is an error, we should fix the error if possible. So like if somebody entered it in wrong, then we need to fix that. Or just delete the data if you can't. If the data is correct, we would leave it in the data set though. For this problem, we will suppose that we examined the data and found that the outlier was an error. And so therefore we will continue on, delete the outlier so that we can explore how it affects the results as a learning experience. Okay, so let's go ahead and do that now. I'm going to go back over here to my list and let's see. Oh, look at that. The very first point is where the outlier is. So I want to clear that point, or can I, let's see, can I delete? Did that do it? I guess it didn't delete. Oh, let me try that. Can I delete that? Okay. So I'm going to highlight the 175 and delete that. Okay. So now I've deleted the outlier. And I want to recalculate the value of R and see if the correlation is any stronger. And to get that done, I'm going to rerun the linreg t-test, right? So I'm going to press stat, arrow over to the test drop-down menu. I'm looking for linreg t-test. When I hit enter, everything looks about the same. I'm going to press calculate. And remember, I'm getting this data type error. And so the fix on that, well, I took Christian's suggestion. And here's what I'm going to do to fix this. I'm going to go over to y equals and clear everything out over here. And also take some time out to clear all your lists, right? So I'm going to clear my lists out. So I'm going to clear list 1 and I'm going to clear list 2. All the functions cleared out here. And I've got a completely empty list. Then what I'm going to do is I'm going to go ahead and rerun the linreg t-test with the blank list, and that's going to throw a different error, but at least it gets the calculator off of that previous error. So now I'm going back in there and I'm going to re-enter in the data. It's ridiculous, but I got to re-enter in the data. With the exception of the outlier, and then I rerun linreg t-test to get the new So going back over here, I'm going to ignore the first point because, of course, that was the outlier.
Tim, you put in 7,071.
Okay, assuming I got all that correct, now I'm going to rerun linreg t-test. And I should get the new result now. Okay, and so there it is. I've got my new regression line equation. Notice the standard deviation is a lot smaller this time, went from 16 to 9. And notice the value of R is 91%, so that's very significant, right? If you take a look at the graph, it looks like that. And of course, there's not going to be any outliers this time. You could play the same game and find outliers, but you're going to see, oh, there isn't any. So that's how you use standard deviation to find outliers.